Good day to all of you watching this presentation here today. We are really thrilled to be here with you and to be able to discuss with you about sustainability. What we are going to explore here today is how here in our company, Typsa, how we merge together sustainability and BIM in order to make more efficient projects. We would like to introduce ourselves first. My name is Cristina Roson. I am the Sustainability Manager for the Typsa Group. I have international experience and I have been working for diverse and different projects from airports to office buildings and master plannings.
My name is Eva Orozco Ramirez, and I am the Digital BIM GIS Manager in the area of transport infrastructure here at Typsa. I started my professional career internationally in the field of construction, where I realized how BIM methodology could help. And of course, we are both aware of the importance of incorporating this sustainability into projects. A little bit of presentation about our company. Typsa, as you know, is a leading consulting engineering group providing solutions in transport and mobility, and water, clean energy, green buildings, and sustainable urban planning. We have 57 years of experience, and we are located in over 40 countries.
Okay, we are going to start the presentation here after our introductions. Well, first of all, we would like to tell you and explain how we are going to approach this presentation today. As we have already said, we are going to tell you how we apply this BIM methodology in our projects and how we marry together both BIM and sustainability. For that, we have structured this presentation first talking about the life cycle of the projects. We think that it's really important to have that in mind and take that into consideration, because depending on the specific life cycle phase of the project, the tool, methodology, and structure that we are going to apply to this project per se, it's going to be different. This is really important. And as you all know, we don't have one fit all solution for every project. We have to study the project prior its design to understand better the performance of this building, infrastructure, whatever. So we are going to start introducing these life cycle project phases for you to understand which specific tool we usually apply in each phase of this building, project, infrastructure, whatever. And then we are going to divide that into the scale of the project. As you know, this is not the same thing to study, for example, an office building compared to, for example, to a master plan project, which is obviously bigger. And after that, we are going to explain that and divide that into architecture, which is my field, and infrastructure, which is my colleague's field. So this is the approach that we are going to explain here today. So as you can see here on the screen, the main phases for us in this project and a study of the how sustainability applies or affects the project itself. For us, they are going to be the most important ones, the first two, pre-design, of course, and then design. Because in these two phases, we are going to explore further how this sustainability applies specifically to each project. And for better understanding, we have compared these basic phases that we have summed here into how they are compared to RIBA stages, which is best to understand how this RIBA phase relates to these specific phases. So, and here we are going to start explaining you how we use in this pre-design phases, this early on the design phases, how we use this methodology. For that, we usually do some initial sketches, concept model designs, in order to have like this basic shape to understand the project in this specific location, which is really important to understand, and this is going to define the project methodology. It's the specific location of the project. We have to first understand the specific climate, the specific location of the project, because this is going to inform the design. This is along with other features of the specific project architecture and other characteristics. Climate is the most important part and so crucial into the design process. This is because, as you know, this is not the same thing to design a project, for example, in Saudi Arabia or, for example, in Canada or other different locations around the globe. Even in, for example, let's say Latin America, for example, let's say Mexico, the design techniques and the bioclimatic architecture principles that we are going to apply, they are going to be different, because even though in the same country, the specific altitude of this specific city or part of the country are going to be radically different. So climate is going to be the first thing that we are going to study and analyze in this first part, in these early phases of the project. So after having that into consideration, and after understood that we have understood how this climate is going to inform the design and the specific conditions, let's say, for example, in these colder places, we are going to need to protect our building, our project from the severe conditions that we may suffer. So this, as I said, this is going to be crucial for the project. After that, we are going to have this idea on how we are going to design the project. If we want a more compact project, the capacity of the project, the shape itself, for example, or other different features and characteristics of the project. So we have this first shape, and after we have decided and designed along with our colleagues these specific conditions of the project, this is when we, as my sustainability team, along with our BIM colleagues, start designing and analyzing the specific design. For that, for example, we use a well-known tool which is called Forma. This is going to give us a really quick understanding, really quick understanding on how the project is going to perform in terms of sun exposure, lighting, in terms of daylight of the project, how the surface are going to receive this sun exposure, if we are going to have any kind of overheating in every of the facades. So for that, we usually run different analysis, meaning, for example, we, for example, run specific and crucial days along the year, like, as you all know, summer, winter, spring, fall, to understand how the project is performing in these specific dates of the year. But as you all know, climate change is so important. So this is like a quick guide to understand the performance of the building, but we have, of course, to take into consideration other different things. And this is part of another different study related to climate change. But as I was saying, this is going to be like the very first part of these studies. So having that into mind, we are going to put you here a video in which you are going to see how we approach this design process in a specific project. So This is a project in the northern part of Spain. This is Cantabria. This is a healthcare project. This is a hospital. So as you can imagine, the location here is going to be really important to understand the amount of light we are going to have in this project, how this sun exposure is going to affect the surface of the project. Also, it was really important for us, the privacy of the patients in this case, along with the workers that are going to be there working. So we want the comfort and well-being of both occupants, transients in this case, patients, and of course, the workers there. So as you have seen along this presentation, this video, we started with a really basic shape in which we had this orientation, but we noticed that sun exposure was really important. So we decided to break this basic shape into different parts to understand how we could gain more light and daylight into the buildings, into the spaces, and into the different floors and levels of the project. So that's why we started with this basic shape, and we transformed that in this kind of stepped with different steps along the shape of the project. So in this case, we have different orientations, but because after that, that transformation of this basic shape, we transform that into 3 different buildings that help us solve the problem that we had in this specific project, and make it bioclimatic, incorporate this bioclimatic specific design and structures. Also, as you can see here, this basic tool, this basic analysis with this tool help us introduce other elements, like, for example, vegetation, to use the prevailing widths to make this open space better for the final occupants of the building. So as you can see, so sum up in a very brief way, this is our methodology approach for these basic projects. So I'm going to show you a different example of different project. This also relates to our methodology. This is a project in Saudi Arabia. So again, the different location and climate that we have to take into consideration in the very first phase of the project. And after that, we designed, along with our colleagues from design, three different designs to understand how we were going to approach and address the client needs. In this case, they wanted a lot of privacy because this was going to be a hospitality project. This is a hotel, high luxury hotel in Saudi Arabia. So for that, we use these patios and plazas inside of the building, and then we transformed that and we broke that shape into other different ones in order to make this natural cross ventilation along the different buildings and shapes of the project. Of course, in this case, as you know, in Saudi Arabia, we have a lot of sun exposure and overheating. So we had to protect the facades of the building and the building envelope with different elements. So after this initial study, we could understand which facade were going to be the most exposed one and the ones that really need to have any other kind of protection, for example, like vertical fins, overhangs, louvers on, other techniques of bioclimatic architecture to protect these specific facades. So this is also a really good example of our methodology, how we study the project first and how we analyze these options, not only with our sustainability team and our BIM experts to understand all of these features of the sustainability and bioclimatic design, but also with our design team, our architects, engineers, and how to make these projects more efficient. After that, after we have decided this project, the basic shape, the basic orientation of the project, which are like the first steps of our methodology, A second approach in this early design stages is going to be the energy efficiency itself. So for that, we use two different tools like Insight or Green Building Studio, both from Autodesk, as you know. So after we have this basic shape, we run this model. We decide what kind of equipment, HVAC or other kind of equipment the project may have. Of course, always this is pre-designed and this is like early on the design stage. So probably we don't really know which the equipment is going to be in the end, but we have like this basic idea. So this is going to give us an enhanced energy analysis and sustainability insights because after this preliminary study, as you are going to see here in this slide, this is the insight that the program is going to give us. We are going to have on the left, you see this bar in which the program, this tool is telling us which is our specific energy consumption in the building compared to an international standard. This international standard is ASHRAE 90.1, which probably all of you know. This is the standard that international assessment tools like LEED or others use to understand the energy performance of the buildings. And this is an international renowned standard. So this is a really good point of comparison in terms of energy efficiency for the project, because we know in this case that we are above that line. So we have to reduce the energy consumption. For that, we have different widgets. This is how the program calls them. We have two examples here out of 24, I believe, in which we can play with this widget, understand, and if we move from left to right and the other way around, these specific arrows, if we are going to improve or enhance the energy performance, or the other way around, maybe we are going to make it worse. So, for example, we have here the window wall ratio. So if we have in mind, for example, that project in Saudi Arabia, if we improve that ratio between this window wall, probably we are going to have more sun exposure, meaning more overheating, more meaning more necessity of equipment and to make the project more efficient after all. So this is going to give us more specific consumption. So this is a really good tool to understand how to improve the energy efficiency of the project. So this is how we approach these project buildings in these two first life cycle stages. And after this, my colleague Eva is going to explain you the same process applied on infrastructure buildings, infrastructure projects, sorry.
Thank you so much, Cristina. So now we are going to focus on the infrastructure area of a pre-design stage project. Here you can find the workflow that we in Typsa usually follow for this stage. We have like two kinds of projects. We can find a complex project, like for example, I have in my mind a cable stage bridge or maybe a steel bridge, for example. And on the other hand, we can find a less complex project, for not say a simple project, because I guess there are not simple projects. So in the first case, the workflow we usually follow is to place on infraworks with the ground and the environment, buildings, and so on, the structure or the infrastructure that we need to place on this platform. And then once we have this information, we export this to a design software Depending of the project, we can use Revit or we can use Civil 3D, so that we can improve in the software the level of detail that is required. Once, well, not once, but at the same moment that we are implementing or we are improving this level of detail, we need, in this case, related to the sustainability, we need to add or we need to introduce information or define the information on the software about the material for each element. Once we have this material defined or implemented, as well as the level of detail achieved, we have two options to follow. One is to export all this information and import to a database, as could be EC3 or OneClick, for example, and calculate the carbon footprint on this database, and then go back with this information and these calculations to our models. And on the other hand, we have plugins or connectors. That's the second option. We have plugins or connectors, on Revit, for example, that can help us to calculate this directly on this design software. As for example, we work with Talica and sometimes with OneClick too. So that is the workflow that we usually follow to on a complex project. And on the other hand, we have the less complex project in which we work directly on infraworks. We place the road, for example, we define all the lawyers, we can define the naming convention of the materials in this software directly, so that once we have all the information defined and all the alternatives and all the elements implemented on this model or created, we can export this information directly from InfraWorks and import this information or this output from InfraWorks to this database that I have commented. Well, as you can see, this is some pictures or some part of the workflow that we can follow when we have a complex design. This is a bridge and on InfraWorks, and then we can export this to Civil 3D in this case. Once we have this level of detail defined, as I said, maybe with help of some tools like Dynamo, we can introduce this information that we need, or maybe directly through Civil 3D, we can define this material information. And that's the other option in which we can work directly on InfraWorks. Here you have a picture or an image about how we can define the material on elements with the naming convention that we need. And then we can export this information as a CCV format, and then we can import this to a database, the database that we need work on or whatever. Now I would like, following this workflow, I would like to share with you an example that we developed here. You can find a footbridge that was was placed in the north of Spain, and in where the sustainability was one of the main points to decide one or another walkway. In this project, the following considerations were taken into account. Related to the material, as a first point, we try to choose or to introduce, or to choose recyclable, low maintenance, prefabricated materials, or those that could be reused after dismantling this footbridge. Another point to take in consideration, or we took in consideration in this project, was the proportion of settle for pedestrian. The third point that was very, very important was the lighting ratio for pedestrian from one side to the other of the walkway. The client requested a platform continuously illuminated, so avoiding dark areas. In this point, we placed a lot of emphasis on the potential for the structure to be energy self-sufficient and to provide power to the luminaries, ensuring consistent light across the entire walkway. And the last point that we took in account in this was the calculation of resilience in the face of hard conditions. We cannot forget that we are in the north of Spain, and we have hard weather conditions such as strong winds, rain, and environmental effects. So after considering all these factors, the alternative that stood out from the rest was the white walkway that you can see in the first picture. That, despite of having higher maintenance due to the white painted steel, it exhibited greater compactness. That means better resistance to environmental weather conditions. And it also provides better settle for pedestrian and improve lighting and solar glass for self-sustaining lightings. So that was the alternative chosen. Okay, this is another technique that we usually use in Typsa. It's the GIS platforms that have, as you know, a lot of data inside. This is an example of a metro line that we had to pre-design. We propose the two alternatives that you are now watching on the video. We had the green and the blue one, and we took into account not only the environmental conditions such as biodiversity, flooding, protected areas, and so on, but also community support of the social part that is contained also in the sustainability process. It was very important to study the distance to hospital, that are the cycles you are watching on the picture. Those cycles represent emblematic or important points on the city, such as hospitals, as I said, educational buildings, schools, and for sure, meeting points with the bus line. So here, with this example, you can see that we can consider not only environmental factors, but also the social aspect involved in sustainability. And all this kind of data, we can find all this kind of data in GIS platforms. And the last slide I want to share with you related to this infrastructure part is the generative design that we usually work with in Typsa. On the left, well, I suppose that you know about generative design, but a little introduction if you don't know what it is. It is a design process that involves using algorithms and computational models to explore several design options and generate solutions based on specific criteria. So we can obtain thousands of optimal solutions according to each situation. Okay. Uh, Not only we can input infrastructure positioning parameters, but we can also limit options and alternatives to sustainable parameters such as the amount of emission from specific materials. On your left, you can see an example of positioning and quantity of solar panels based on Earth movements, materials emission, and positioning perimeters. And on the right, I'm going to click on play. There is a video there is a video about an internal software we have developed. The name is PVGrad, and it contains, once you have the solar panels placed as in the left part of the slide, once you have these solar panels placed, it takes into account not only the terrain, but also the calculation of the best panel rotation, depending on the sunlights. So these are techniques that we usually work with in Typsa. And now I'm going to left the control to Cristina for the same. She's going to talk about generative design as well, but in the building area.
Yeah, thank you, Eva. Well, as Eva has really well explained our approach to generative design, I am going to explain the very same thing but apply to a different scale that we have talked previously. We have talked about a really a smaller approach of projects like typical project office buildings, healthcare, hospitality, that kind of buildings. And this is the generative approach applied to a master plan project. This is also a master plan project that we are designing in Saudi Arabia as well. We work a lot of in this country, as you can see. So we apply this technology to better understand how we could design this project. So we are going to see different videos to understand this generative design process. So I'm going to explain that along the videos, but for you, for better understand, we used different scripts and different techniques and features to model this master planning. So we had into account the street widths versus plaza spaces, building heights, solar radiations, and well, different kind of vegetation that we could apply to the project. So as you can see here, this is from the top view of this project. We the program is calculating here this relationship between the open space, the building, the constructed space, buildings versus heights, etc. And also, as you can see here, as this project is in Saudi Arabia as well, it was really important to have into account this sun exposure on both the buildings and both the open space, the public space, these plazas. So it was really important to bear that in mind, because depending on that specific feature, the design that we finally were going to apply was going to be different. This open space, if it was going to be bigger, probably we should need to take into account how to reduce the heat island effect on these surfaces and use different techniques like more vegetation, open space, permeable pavements, lighter pavements, and all of these techniques to reduce this heat island effect on these master plan projects. So the next video we are going to see is how this relates to the building height and this specific relationship between the constructed and non-constructed area. So you see here, this is we have this simulation runs along the year. So you see different options compared to different days along the year. So it's really interesting because this program is telling us if we have, for example, more narrower streets, for example, related to these building spaces, the sun exposure is going to be lessen if we compare that to more open and big spaces. So this is also a really important methodology we also take into account when designing larger projects like this master plan project city in Saudi Arabia. And finally, we are going to end with other phase of these design phases. We have talked about pre-design, design, and this is going to be the latter, latest option into the design. We here, well, I believe Eva has been explaining you about these carbon emissions and this carbon footprint that we bear in mind when we design infrastructure projects and of course building projects. So finally, this is going to give us the final view on how apply sustainability into projects. So when we have this basic shape, the energy performance of the building, finally we have to decide which materials we are going to finally use in our project. So for that, this is when carbon methodology comes into action. So we have these different designs, these different materials, and then we compare these different materials and comprehend their carbon footprint impact on our project. So we run them in this Carbon Designer software. We use different softwares for that. We have used Talicat, we use EC3, we also use One-Click LCA. All of these softwares depends also in the scale of the project, the need and inputs or outputs, the inputs we may have and the outputs we really want to obtain from this software. So we compare designs. For that, it's also really important to have material information like EPD, fact sheets and other kind of information. And then we obtain the result when we have compared these different models. And this is a really good understanding for us in terms of carbon emissions for a project, because in some cases we can decide which is going to be the best material and best approach for this project. For example, we had to design once an airport in which we could perform this life cycle analysis to understand which was going to be this impact related to carbon emissions. We could inform the design and change the structure of the project because we understood that the structure that was being proposed for this specific project had a really huge impact in terms of carbon emissions. So as you can see, this is also a really important tool to have into account in these preliminary phases of the design project. And finally, we also understand and benchmark these results with other international assessment tools like LEED, BREEAM, and Vision, or other different frameworks in terms of sustainability. So this is how we apply these different methodologies and approach into our projects in terms of BIM and sustainability. We hope that you have enjoyed our presentation. And now, if you have any kind of questions, comments, jokes even, please feel free to reach to us. Thank you very much.
Thank you.
Thanks a lot, Cristina and Eva, for a great presentation and for providing some insight into how Typsa works with sustainability and BIM. I think we saw a lot of great solutions here. We do have a few minutes left for Q&A. You might want to take those questions on your own. Is that okay with you guys?
Yes, sir.
Yes, sure.
Yeah, all right. So I think there are a few there. Yeah.
Okay, let me see. I'm seeing the first question, which countries are the EPDs from? If you don't mind, Eva, I'm going to answer that one. For this, it also, as we have been saying in this presentation, it depends on the specific country we are working. So if we are working in a project in Spain, we use the EPDs database we have here. So this makes more sense because, as you know, all the impacts depend on the specific project because, you know, we have transport, we have the electricity mix, so it's going to affect the final results and impact. So if we have that specific EPD for the country, we always use that first.
Perfect. Next one. So Eva, there might be one here. What does BIM contribute to sustainability? Or is that for you, Cristina? That depends.
No, I think I can answer this one. Yes. So in my opinion, the basis of the BIM methodology, not only in sustainability but in all areas that involve in a project, is to have a centralized model with a lot of information of the life cycle of the asset. For sure, in different stages of the project. So from the model that you can develop, or we can develop, everyone, you can not only extract automatic information that is generated as while you are designing, but you can also add and implement new information. So on this basis, specifically with the methodology in a pre-design and design phase, that is what we do in Typsa in general, I think BIM can help in decision making in this point, in this main point. Not only is important to decide where the alignment, for example, of a road goes in case of an infrastructure, but today, and with the goals that countries are proposing to improve our lives, I think it is necessary to impact as little as possible on what surround us. So therefore, in this case of calculating this emission that we were talking about, making decision of on the quantity of materials, or choose between one material or another, or for example modifying the design to reduce these quantities, or calculating the displacements, is information that we can be extracted and decide through the models with this BIM methodology. Sorry.
Yeah, I think you showed a lot of great examples how you do that in your daily work. So perfect. One more question, and we do have a couple of more left, perhaps. Do you believe there is a significant difference in the working environment for architecture or infrastructure? That might be for you, Cristina.
Okay, thank you. We try here in our company, we try to apply the same methodology and have the same work environment, both for architecture and infrastructure. The thing is here that, as you know, the projects are so different. For example, in the built environment, meaning in buildings, we have this environment more controlled, but for infrastructure, for example, we have different approaches because we may encounter, for example, bridges, roads, train stations, aviation projects. So the methodology is the same at the end of the day, but we have to understand the specific project we are designing for. So no, I don't think that there is a really significant difference, but we have to understand our project first, I'd say.
Yeah, so you try to apply the same standards as far as possible across the two different areas.
Exactly.
Yeah. So could you describe a bit more the technique used between the databases and BIM models? Eva, is that one for you, perhaps?
Yeah. I can answer this one. Yes. So the workflow I share with you at the beginning of my part of the presentation, I saw that once you are on, well, even in InfraWorks or both in Civil or Revit, for example, the main or the key in this case is the data that you have on models, as I said. While we are implemented or improving this level of detail on the design, we need also to implement the information that we need for mapping with this database. So we can export this information and import through one click or Tallycat, for example, or the other option is to go through the plugins. But the plugins is true that you work on the same at the same moment that you are designing, so you can see while you are designing, you can see the emission, the real emission at the moment.
The impact it has.
Yeah. So you can change. You have this. You can change maybe, I don't know, the thickness of the slab or whatever. And on the other side, if you export all this information and you import to this database, you will have the result of the design. So once you have these changes, maybe on the models. So here the key is to implement very well the information through the models, to have a very well naming convention or structure of the material namings that you are implementing on elements. And another point that it's very important is the way that you are modeling this design, but is not the same to design or model something as a point or as a square than if you put some volume in this element, because you are going to have different quantities to calculate this carbon emissions.
Makes sense.
Yep.
Definitely. So one last question. We are 2 minutes after. We have one left here. So do you think there's a difference if we use these tools in different phases, such as construction? That might be for you to, Cristina, to finish up on that one.
Okay, yeah, well, as we have already been discussing during this presentation, to understand the specific project life cycle and the specific tool that we want to use and the outputs we want to obtain, it's paramount. So yeah, we can't not apply the same tool for construction, for example, because the specific phase is totally different. Yeah, absolutely.
All right. Thanks a lot to both of you. It was a great presentation. I think that's all for now and today. So thanks all for the participants for listening in. Yeah, that's it from us.
Thank you so much for being here.
Have a nice day.
Bye.